Okay, in this video we are going to do long division polynomials, but this time these problems will have a remainder. And these are the two problems that we will solve together, but if you want to pause the video and attempt them, feel free. Okay, so this is the first one, and our very first step is to kind of rewrite this. So we're going to have x squared minus 2x minus 15, our numerator, is being divided by x minus 1. We look at the highest power. This highest power is an x squared. This highest power is an x. So we think to ourselves, x times what gives you x squared? And that's going to be x, because x times x is x squared. And I'm going to put it right above the x here. Now we take our x, we times it by x, we get x squared. X times negative 1 is negative 1x, or negative x. Now we take this piece and we're going to subtract it by this piece. So this is already positive, so make it negative. This is negative, so make it positive. And we're going to combine. X squared minus x squared is 0. Negative 2x plus x is negative 1x, or just negative x. And then you're going to bring down the negative 15. So negative 15 here. Okay, now we think to ourselves, x times what gives you negative x? X times negative 1 gives you negative x. So you'll put a negative 1 here. Okay, then you put negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Now, we take this piece, we're going to subtract it by this piece. So this piece is already negative, so make it positive. This is positive, so make it negative. So negative x plus x is 0x. Negative 15 minus negative 1 is negative 16. So we do have a remainder. And so we're going to say minus, or you can say plus, negative 16 divided by x minus 1, our denominator. And then this right here would be our final answer. So now again, for these problems, there's a remainder. And so this is our final answer, x minus 1 plus negative 16 divided by x minus 1. And we're going to do another problem. So same procedure, we're going to rewrite this as 4x to the fourth. Now you notice this was raised to the fourth, then raised to 2. There was no x cubed. So you're going to put plus 0x cubed as a placeholder minus 2x squared. There's no x, so put plus 0x as a placeholder, negative 1. This whole thing is going to be divided by our denominator, which is 2x squared plus 5. Okay, so we see here our highest power is x raised to the fourth. Here our highest power was an x squared. So we think to ourselves, 2x squared times what gives you 4x to the fourth? And 2x squared times 2x squared gives you 4x to the fourth. So you'll put a positive 2x squared here. Now we're going to take our positive 2x squared, we're going to multiply it by 2x squared, and we're going to get 4x to the fourth. 2x squared times 5 is 10x squared. So we'll put a plus 10x squared. The reason I didn't put it here is an x cubed, and here is an x squared. So 2x squared times 5 is 10x squared. And then we put our little line. So we're going to take this piece, we're going to subtract it by this piece. So this is positive, so make it negative. This is positive, so make it negative. 4x to the fourth minus 4x to the fourth, it becomes 0. 0 plus 0 is 0. Negative 2x squared minus 10x squared gives you negative 12x squared. You bring this stuff down. You bring this stuff down. Plus 0x, or yeah, you can put 0x minus 1. So now we do our exact same thing. Highest power is an x squared. Highest power is an x squared. So we think to ourselves, 2x squared times what gives you negative 12x squared? And we know it's going to be a negative 6, because negative 6 times 2x squared is negative 12x squared. Negative 12x squared. Negative 6 times 5 is negative 30. So our next step, so we take this piece, we're going to subtract it by this piece. So this was negative, make it positive. This was negative, make it positive, and we're going to combine. Negative 12x squared plus 12x squared becomes 0. 0 plus 0 is 0. Negative 1 plus 30 gives you positive 29. So we're going to say plus 29 divided by our denominator, which is 2x squared plus 5. 2x squared plus 5. And then this right here is our final answer. And that's pretty much it for long division polynomials with remainders.